So thank you very much for being on this episode of BetterTech with us. Our aim is really to introduce new software, SaaS platforms, CTOs to the world, as well as on our other episodes, we try to see where the industry is going and bring in advice from the thought leaders. So in this episode, we'll talk about your startup and how it all started. So how about you go ahead and introduce our audience with yourself, what your name, your company, what do you do?
Okay, my name is Al Wegener, Wegener. My company, my startup is Anacode, Anacode. And Anacode makes all cloud storage, and eventually all storage, faster and cheaper. Mm-hmm. So if you do, us old guys call them storage reads. The new guys will call them RESTful get and gets. And if you do storage writes, which the new guys will call RESTful puts, mm-hmm. Anacode will make those transactions all at least 2 times faster. And I'll explain a little bit about how that works.
Okay.
The other thing we'll do is while we're making your data transfer twice as fast, we will lower your cost of storage, starting on AWS and then moving to Microsoft Azure, then moving to Google Cloud Platform. GCP.
So I'm assuming you must be compressing the data in the process, and that is reducing.
Bingo.
Okay.
Yes.
So
now,
go ahead.
What I was going to say is that lossless compression has been around for a long time, since 1977, when Abraham Lempel and Jacob Ziv, 2 Israeli mathematicians, were working at IBM in Haifa. Mm-hmm. And they published a very famous paper that has had thousands of references over the years, explaining how Lempel-Ziv compression, lossless compression, works. One of the things I realized in the last years is, how come nobody's ever improved upon gzip lossless compression? Mm-hmm. Well, there have been some incremental improvements, but nobody has attacked the way that lossless compression works in a fundamental way for 43 years. In other words, 1977 is 43 years before the present day, 2020. So what Anacode does is we say, well, how come everybody's using a sliding window? You have some data, and then you look at the new data and you say, did the new data appear anywhere? At least 3 bytes of the new data appear anywhere in this sliding window that we have. Mm-hmm. gzip's original window size is 32 kbytes.
Okay.
So it basically says in the last 32,000 characters has the new stuff, at least 3 bytes worth, might be 5 bytes, might be 10 bytes, appeared before. And if it has, you send a pointer to where the data appeared before in the sliding window, mm-hmm. and then you send the length. And the length for the English language is somewhere between 5 and 7 bytes. And that can be further encoded.
Okay.
This technique is what Abraham Lempel and Jacob Ziv invented in 1977. Mm-hmm. And it hasn't been improved very much in 43 years.
Okay. So
what Anacode does is very different. What we do is we say, let's say you had a gigabyte of data to compress. Instead of sliding a 32 kbyte window across the entire gigabyte, which takes a while, it's not that long, seconds. Anacode says, let's exploit some new software that's available only on the cloud. And that software is called microservices. Right. The new developers will consider this as, they also may call it containers plus Kubernetes. Mm-hmm. Kubernetes being a scheduler for container software. And if you think about modern data centers have thousands, often tens of thousands of servers. The job of cloud providers like AWS and Microsoft Azure and Google Cloud Platform is to schedule software to work to be done on as many servers as possible without letting the customers see each other's data. So that's where the security aspect comes in. Mm-hmm. What Anacode does it says, let's divide your data into, say, 1,000 pieces, and let's have 1,000 microservices software instances. And the reason I pick 1,000 is that's the default maximum number of instances that AWS, Amazon Web Services, will launch for their microservices service called AWS Lambda.
Mm-hmm.
So if you take a gigabyte and divide it into 1,000 pieces, you get 1 megabyte pieces. And so AWS Lambda instance number 1 compresses the first megabyte.
Mm-hmm.
AWS Lambda instance number 2 compresses the second megabyte, and then AWS Lambda instance 1,000 compresses the last megabyte of the one. And so 1,000 threads times 1 megabyte is a gigabyte.
And it's all happening in parallel.
This is all happening in parallel. And the cool thing for Anacode is that we didn't have to do anything except create 2 pieces of software, an encode instance for AWS Lambda and a decode instance for AWS Lambda. Right now, we're just talking about encode. So you do all this in parallel, and with Anacode's slowest encoding speed, which is around 10 megabytes a second, maybe 5 times faster than gzip's one-thread encoding speed, you'll finish up your gigabyte of compression in milliseconds. And if you take the one-thread speed, 10 megabytes per second, and you multiply it by 1,000 threads, you're encoding data at 10 gigabytes per second.
Mm-hmm.
Now, I mentioned that Anacode also, Anacode also has faster compression speeds. That's because the very first step of Anacode encoding, and this is not confidential or anything, the first step says, what the heck is this that you've given me? Because if you know it's text, then you can kick in a text-based compressor. Mm-hmm. If you know it's binary integers, let's say Internet of Things sensor data, then you kick in an encoder that is appropriate for binary integers, 8-bit, 16-bit, 24-bit, 32-bit, it doesn't matter. Anacode figures it all out. Then if you had floating point data, binary floating point, which is very common in AI and machine learning and high performance computing, HPC, then Anacode says, oh, well, let me kick in the floating point compressor. And if it's none of those things, if it's not already compressed, it's not binary integers, it's not binary floating point, then we stick the Anacode text compressor on it. Now, keep in mind that all this is happening in parallel.
Mm-hmm.
So with every 1 megabyte chunk or whatever the block size is for Anacode, Anacode basically makes the decision every block size what the appropriate encoder is. So if you had a mix of text and IoT and HPC data, then every megabyte you get a chance to make a new decision.
Mm-hmm. Okay, so that was a good tech explanation of what you guys do. Now let me ask you, and I'll have a couple of questions related to that, but let me ask you, for a everyday CIO, that at what point in time Anacode's use case really kicks in. So for instance, I'm a CIO of a company running some infrastructure, and I'm saving my files on AWS. And at what size and at what overall economy you feel that Anacode starts providing you substantial benefit, both in terms of speed as well as cost saving?
Well, this is the interesting part. Price is a fungible thing. The company is basically deciding how much profit it wants to make, mm-hmm. given its expenses.
Right.
So cost plus profit is price. Anacode has decided that a 35% discount on cloud storage is compelling.
Mm-hmm.
So instead of, let me use AWS S3 as an example. Today, people are paying $21 per terabyte per month.
Okay.
If you go to AWS's website, you'll never see any dollars per month numbers. And the reason is that they would rather say we charge 2.1 cents per gigabyte per month. And if you say cents per month to engineers, they get all happy and they say, oh, it's free. And they stop doing math. That's a bad thing.
It all adds up at the end.
Yes. Now, I won't say how I know this, but 20% of AWS and Microsoft Azure and GCP revenue is from storage.
Mm-hmm.
So AWS today is running at 10 billion per quarter, billion with a B, US.
Mm-hmm.
So that means that they're getting 2.5 billion per quarter from storage, 2 billion per quarter from storage.
And it's not in their interest to compress.
What's that?
It's not in their interest to compress before storage.
Oh, no, that's not true. Because the numbers are so big, anything they can do to make the data smaller that they have to store while still returning the data to their customers is a good thing.
Mm-hmm.
So I won't say how I know this, but AWS and Azure and GCP all use gzip lossless compression to increase their storage profits.
Mm-hmm.
Now, I will mention something that I think will be of interest to your listeners. Mm-hmm. Let's do a thought experiment. If you take AWS's S3 storage price of $21 per terabyte per month, or 2.1 cents per gigabyte per month, same number. Then you say, well, $21, that's a lot of money for a terabyte, because I can go to, in Silicon Valley, you can go to Fry's Electronics or Best Buy or even Amazon's website, and you can buy a 4 terabyte hard disk drive for $100 US. Yeah. So $100 US for 4 terabytes is $25 per terabyte. Mm-hmm. Compare that with them paying $21 per terabyte per month. Now, on AWS, they make 3 copies. So, it's not exactly right, but you could say, well, the return on investment for cloud storage cloud storage vendors is 3 to 4 months. So in 3 to 4 months, they've paid for a terabyte, even making 3 copies. And if you talk to any business people, a 3 to 4 month ROI, return on investment, is a really good deal.
But they're running the centers as well. It's not just the cost of hardware to store.
Yes.
So maybe
this is true. But as a first approximation, almost everything that they use in storage is for buying hard disk drives and solid state disks.
Okay. So returning to the original question, you help, how much, you say that you can help by reducing these costs by 35% or what?
Yes, and Anacode's model is actually quite simple. It says whatever you're paying today, and on AWS for S3, they're paying $21 per terabyte per month. Anacode's charge for the exact same storage requirement is $13.65 per month.
Sure. And at the same time, you're giving almost double transfer speeds.
Yes.
Okay.
And the faster transfers is, I have 58 US patents, and hopefully numbers 59 and 60 will be worth a lot of money to Anacode. And I filed a patent. In the US, they have provisional patents which don't have claims, and then you have non-provisional patents. You know this. So Anacode in the summer of 2019 had a reason to file a provisional patent on accelerated data center transfers.
Okay.
So if you think of it, if someone could get 3-to-1 lossless compression on average on all data, then you could reduce storage costs by a lot, by 67%. But we can't compress all data, and for a variety of reasons, we want to have a nice profit. So we say, well, we'll give you a 35% discount. If I were selling Mercedes automobiles, and instead of paying $80,000, you could pay $55,000, 35% less, I think I'd have a lot of business. Yeah. And I'm hoping the same thing happens with Anacode. I'm sure you're aware that the cloud, which also people call digital transformation or migration, is a big market.
Right.
It's billions. And Anacode, for once, I think my timing is good.
Yeah, I really guess so. So, I mean, you were at Amazon, and I was looking at your profile, LinkedIn profile. So, did you get a chance to work on all this? I mean, how this idea came into being?
So that's a good question. I should talk about what I did before Amazon.
Oops,
So for your audience, I was at Amazon Lab 126, employed as a principal hardware architect on a chip design group that was building a chip for the second generation of the Amazon Fire phone. Now, unless you're paying close attention, the Amazon first generation of Fire phone was a beautiful piece of hardware, but it had a lot of market challenges. So it launched in the summer of 2014, June. By September of 2014, the Seattle folks that run Amazon decided they were going to kill the Fire phone.
Okay.
So the team that I was working on, the chip design team, never got to build its chip. But that's okay. So in September of 2014, the entire chip design team for the Fire phone at Lab 126 was disbanded and put in other areas. And as a principal hardware architect, I was moved to a machine learning group. And in the machine learning group, I did some very interesting stuff that I can't talk about because of non-disclosure stuff, confidentiality agreements. But I got a call in October of 2014 from a guy who worked for Amazon Web Services. And this is not unusual because as a principal engineer, we're supposed to be the glue between all the various pieces of Amazon. They have fulfillment centers, they have Amazon Web Services, they have the surprisingly successful Echo, which was done by Lab 126. And I mentored some of the engineers that
I have a story related to Echo, and we are working with a AI incubator, and they had this speech AI technology around speech some time back, and they told us how Amazon kind of forced them to first sell their tech, try to hire their people, and then eventually they came up with their own Echo. And so he told me some interesting stories about that. We probably will discuss it some other way. But you mentioned Echo, so I thought to mention it over here.
Yeah, that's and I've heard similar stories. I've heard that Amazon has a venture group, and the venture group tries to suck all the information out of potential startups that they consider funding to see if they could use that idea internally. And there have been some recent newspaper articles about that, or web articles. Amazon, I worked at Amazon, and I have to say, Amazon is a great place to work.
Absolutely. So we are working with another startup who recently got their Series A, and they are all ex-Amazon guys. And I must say, these are some of the very smartest guys we are working with so far. I mean, we've been working with them for like a couple of years now. They're running a team over here with us, and yes, so I talk to a lot of ex-Amazon guys, and I see them. They're pretty smart, and that tells me something about Amazon's culture as well, which is actually a good thing.
Yeah, and it tells you something about the culture if they can't hang on to those people. Yeah. So back to my story. In September of 2014, in October 2014, I got a call from Amazon Web Services in Seattle. The guy says, "Mr. Wegener, I understand you're a compression expert." And I said to him, "Well, I've done a little compression. How can I help you?" And he said, "How much do you think you could do lossless compression of 512 bytes of Amazon customer data?" And after I picked myself up off the floor, because I'd never been asked that question before, I said to the guy what most compression researchers would say, "Well, send me some of your data and I'll take a look and I'll give you an opinion." So he was basically asking me to do a compression analytics job. And I did that job mostly in January of 2015. In February of 2015, I finished up, I collated my results, I ran some statistics and wrote the report, 10-page report. So I emailed him the report. He calls me an hour later. I haven't talked to the guy in 3 months. Calls me an hour later, says, "Al, when can we have this magic software?" So let me tell you what the conclusions were. And this is, I hope I'm not breaching any confidentiality with this. I told him I thought I could get 1.5 to 1 lossless compression every 512 bytes. And that was better than they were able to get with a custom version of gzip, where the window size, instead of being 32K bytes, is 512 bytes. There's not a lot of redundancy in 512 bytes. There's a lot of redundancy in a megabyte. So I sent the report. The guy said, hey, when can we have this magic software? And now I need to go back to Samplify, what I was doing before I joined Amazon. For 7 years and $23 million money raised, Samplify was a failed startup. Many people out who don't live in Silicon Valley think, oh, well, every startup wins. No, 70% of startups fail. I was the CTO and founder.
I think you're being nice when you say 70%. I feel the rate is a bit higher.
Maybe it is. But anyway,
by the way, people, it feels like I'm talking to the team out of the seasoned Silicon Valley. They were all about compression and all that. And there we are.
So I have a story for you related to Silicon Valley. I have briefed some VCs, no surprise there. And many of them say, oh, do you know that HBO show Silicon Valley? Isn't it about a compression guy? And they're vague about the compression, but the showrunner, the guy who writes the scripts, is Mike Judge, the Beavis and Butthead guy. So imagine my surprise when I get a phone call. I'm still at Amazon in January 2015. I get a phone call from a former summer student of mine. Mm-hmm. His name was Vineeth Misra. Vineeth was getting his PhD at my alma mater, Stanford, for Professor Taki Weitzman. And if you know the show Silicon Valley, you know that in season 1, there's a thing called the Weitzman score.
Right.
And it's something that Vineeth Misra basically invented, and Mike Judge adopted and put it into the script. And it's the idea that compression is a mix of how much compression do you get and how much work do you have to do to get that much compression. So you can either get more compression or you do less work, and it's the same thing. So that Weitzman score became somewhat famous. And in general, the compression got more airtime thanks to the show Silicon Valley. Right. So my connection is that in January 2015, Vineeth Misra called me and said, Al, I'd like you to be part of a panel discussion at the first Stanford Compression Forum in 2015, where we talk about lossless compression and new uses for compression. So at the time, I was still at Samplify, my first startup ever, doing lossy compression for DSP applications, medical imaging, wireless base stations, wherever you have high-speed sensor data being sent back and forth. And I thought, well, you could do lossy compression of that data, and you might compress it 10 to 1. That would be a hell of a savings for a wireless base station or a medical imaging customer. And as long as we could prove that lossy compression doesn't mess up your final answers. We were working with GE Healthcare at the time, and their chief engineer, Bob Senzig, had a saying. He said, Al, we can't miss Aunt Mabel's tumor. So if word got around, let's say to Siemens or Philips, who also make CT scanners, right, that GE was using lossy compression, then GE could not have word get out that even though they were saving a lot of money, they missed Aunt Mabel's tumor. So if people go to my LinkedIn page, they will be able to see those articles I wrote with people like Norbert Pelk, the chair of the bioengineering department at Stanford, or Bob Herfkens, who is a radiologist at Stanford. And we did the work. We did lossy compression. So I mentioned that Samplify was one of the 70% or more of failed startups. Samplify had an interesting story.
So by the way, what's your stage and how much money you have raised, and tell us about the current stage as well while you're telling.
That's also a good story. So this goes back to the original.
So I guess my audience will be excited. We are getting the real deal over here.
Yes, the real deal is that I am swinging for the fences. I have put $1 million of my own money and that of 2 of my family members and a friend of mine, a good friend, my best friend since 1981, who's now retired, a retired VP at Broadcom, my friend Marshall. And Marshall and I have been best friends since 1981. We met on our very first day of work in 1981. So I have about $1 million into Anacode. We've talked to VCs, but I haven't met the right one yet. And I think it's likely that in the next 3 months, I will meet the right one.
So you're in the process of raising money right now.
We're raising money So one of the mistakes I made at Samplify, and part of the reason that we failed, was that I, as the founder, didn't care about money, which is really strange. So you talk to my wife, she's always like, "Are you kidding? Al is the most penny-pinching German you'll ever want to meet." But
every wife would say that. I mean, that doesn't say anything about you.
Yes. So at Samplify, I was CTO. I was a technical founder, very common in the Silicon Valley area. And I didn't care about like go-to-market strategies or marketing or competition or market size. I didn't know any of that stuff. I started thinking about that when I was at Amazon. I was like, well, why did Samplify bite the dust? And one of the conclusions I drew is, well, I didn't care about money. I didn't know anything about market size or anything like that. So when the compression guy from Amazon Web Services called me, I did a little bit of checking. And eventually I found out that there are billions of dollars of revenue that AWS gets from storage.
Right.
I thought, well, billions, that's like, how big was Samplify's market? And Samplify's market might have been, $200 million, all in everybody in the world, if we had 100% penetration. So, I went to Stanford, so I have intelligence, but a lot of startup stuff is about applying intelligence selectively to the right problem. I realized one of Samplify's problems was I was solving the wrong problem. Nobody cared about lossy compression of ultrasound or CT data. And even if they did care, they wouldn't pay for it. Because
there's a saying in the business that there needs to be a gap in the market as well as a market in the gap. So, I mean...
I hadn't heard that before. That's a good one.
Yeah. So you may find the best gap, but if there is no market, who would you sell to? Anyway.
Yeah. Now, going back to the AWS thing, I found out over the 3 months between October 2014 and February 2015, October, November, December, January, 5 months, that he was asking, 1.5 to 1 lossless compression has no meaning unless you know what the intended use is. The intended use was pretty simple. He wanted to use something like Lambda to compress data in flight before it got to storage. And that would make their Ethernet links faster. So where do I want to go with this? So this guy was spending at the time hundreds of millions of dollars. I can't say what the specific number was. He was spending hundreds of millions of dollars, let's say $900 million, buying solid state disks for, at the time, 45 AWS data centers around the world. So 900 million divided by 1.5 to 1, the estimate I gave him, is 600 million. So I would have saved him $300 million per year in buying new solid state disks. And of course, my algorithm was just general purpose. It just would have run on any AWS server. So there's no reason you couldn't use the algorithm for hard drives as well as solid state disks. And let's just say Amazon and Microsoft and Google have a lot of installed hard drives and solid state disks. They spend a lot of money. Most people know this, the number, that the storage needs are growing at 30% a year. Much of that is machine data, IoT data, sensor data. A lot of it is HPC data, HPC AI ML, floating point data. But a lot of it is still stuff that analytics companies crunch. If you take Splunk or Elasticsearch, for instance, those companies process log files. What do log files have in them? A lot of text. Now, text made me really concerned back in 2017.
So in a way, I would say Amazon has also created opportunities for many. So I was talking to another startup, and their model is around to come into an enterprise, see how they are using Amazon's or any cloud services, and help you optimize your bill. So a lot of people spawn instances, never forget to turn them off, and so on and so forth. Again, you are using their service to compress. So I guess it's a good ecosystem. What do you feel? I mean, you are still early in terms of your need to raise money, but do you feel there's a exit that you have in mind, or exit strategy? Is it through acquisition, public? What? I mean,
yeah, something for you to think about and for your audience to think about is, what would it be worth if Anacode was better than gzip in every way?
Mm-hmm. Okay, well,
and you can do the math on. It's a lot of money. So every man has his price, and mine is very modest. My wife and I have been together for 20-some years. When we met 24 years ago, she already had 4 kids. I already had 2. So on our first date, we talked about, do we want to have any more? And we both said no. No surprise there. So we did the Brady Bunch thing for 14 years. And yeah, back to how much? Not that much. Back to you, Umair.
Okay. We'll see about that, where it goes. I hope I'll do another show with you 1 year down the road, and we have some answer to this question.
I would love that, yes. Now, I can say that given my technical background, I have a lot of contacts on LinkedIn. Mm-hmm. And LinkedIn has helped me realize that those contacts are important. Yeah. I have a lot of contacts at AWS, given I used to work in Amazon, not surprising. But I also have a lot of contacts at Microsoft Azure and Google Cloud Platform. Mm-hmm. I also have a background in hardware design. So I know exactly what to do with Anacode technology if someday you would want to save money on, say, DRAM. Much more expensive than NAND. Much, much more expensive than hard drives.
Mm-hmm. Okay, all we can do is, at this point in time, we can say that you look solid, and we can really wish you well. So,
thank you.
You see any trends? I mean, in the where will all this go in the next 2, 3, 4, 5 years, or all the cloud storage and all?
Well, the general trend is up and to the right, as VCs like to hear and entrepreneurs like to say. Cloud adoption is growing hugely, mm-hmm. and I think that Anacode's timing is really good. The fact that we reduce costs for end users while also making storage transfers faster mm-hmm. is kind of a unique value prop.
Sounds good. So I guess we are at the end of my time. I had a lot more questions, but maybe we can have another episode. So I'll let you speak about the Anacode, and I was actually pretty impressed by the kind of technology you built and where you're heading. So I would love to check back with you in about a month and see where you are, and all the best wishes for you.
That sounds great. Great to talk to you.
Same here. Bye-bye.
Bye.